Okay, as you can see, we are going to talk about the slopes of lines. We've been talking about lines in the last couple chapters. We're going to talk about the slopes, or how they are slanted. When I think of slopes, I don't know about you, but I think of skiing. All right, you ski the slopes. And we can kind of have a correlation between this because these hills have certain steepnesses. If you've ever been skiing, they even have signs. They have like green trails, blue trails, and black trails. The black diamonds, that's the ones I like to go down. I like to go down the real steep ones because that's more fun than the baby ones. All right, but not everybody likes to do those. But I like to go down the steep ones, and those are the slopes. So each one of those hills has a different slope, and that's what we're going to talk about. But we're going to talk about it in terms of lines. So let's just throw a couple lines in here. Let's go with this color. So let's do one about like that. So what do you think about that? That's probably not a very steep slope, is it? It's fairly flat. It's not quite horizontal. It does go up a little bit. That's not near as steep as maybe something like that. Okay, that would be a lot steeper slope. So we're going to talk about those things. And you could also have a slope that goes in the other direction. We'll talk about that as well. All right, so it looks like from left to right, this is going up, this is going up, this is going down. So we're going to talk about the differences between that. So let's talk about the differences between the slopes, and we'll get rid of these. Let's tell you what, let's get rid of this. Let's do one that's a little bit more kind of in between. There we go. There's a nice line right there and a nice slope. So when we talk about the slope, what we're talking about, the book says it's the rate of change, and I would agree with that. I think that's a good way to put it. It's the rate of change, which basically means this. Let's say I wanted to get from one point on this line or this slope to another point on this line. Let's say from right there to there. I could get to it, but we're not just going to go down the slope. How could I get from here to here? What we're going to do is we're going to put this on a x and y axis, and we're just going to go up and down and over. So let's do that. If I was to get from this top point to this bottom point, I could get there two ways. Okay, again, we're not talking about sliding down the ramp here, down the slope. I could get to it. I can only go left and right, up and down. So I could go left and then I could go down, or I could go down and then I could go left. I could get to it either way. Let's do it this way. Let's go down. Let's see if I can match it up. I don't know if I will or not. And then let's go to the left. Oh, that was pretty good. Scooch it down just a little bit. All right, so what did I do? I went from one point to the other. So this right here, we're going down our y-axis. Remember our x and y-axis. So we call this the change in the y. Now they have a little fancy thing, and it looks like a triangle. It's supposed to be about right there. And sometimes they darken it in. It's a fancy thing. It's a Greek letter that represents the change in something. It's called a delta. That little triangle looking thing is a delta. So we say delta y, which is the change in the y. Change in y. We also have going across. So if this is the change in the y and I'm here, now I want to change in the x. So that would be delta x, or the change in x. A lot of times we'll use another word that kind of describes it kind of easy. If I want to get from here to here, we call this the rise. This would be the rise, and this thing from here to here would be the run. Now you could run left and right, and you can rise either up or down. So what do we do here? We were rising, or we rose down. All right, so what do you think, what sign do you think we're going to use when we rise down? We'll use a negative sign. Let's just put that right here. So we'll use negative, and then we're here. Now we have to get to this point. So which way do I have to run? I have to run to the left. Which way do you think is to the left? Running would be negative. And so in order to find the slope of this thing, we're comparing the rise to the run. A comparison. It's a ratio. It's the change in something. So it's the rise over the run. That's how we're going to compare them. We're going to compare how far up and down did we have to go compared to how far do we have to go left and right. So the rise over run. And that's what we use for slope. Now, for some reason, they use the letter M for slope. I've looked it up at some point, and there's a conflicting opinions on why we use the letter M. Basically, I think if it came from like a Latin word or something. It's been a long time since I've looked this up, but it came from a Latin word, and the Latin word had to do something with mountains or mountainous, that kind of thing. So it doesn't absolutely stand for mountain, but you could kind of think of it like that. Okay, you can think of it as mountainous. So M we use for slope. So I'm going to put the word slope right here. It means how steep a line is, right? If this line went steeper, it would have a larger change in y compared to a smaller change in x. That would have a steeper slope. If this went a little flatter, then you'd have a short rise, a short change in y, and a longer run. Right? So the higher the rise is, the higher the slope is. Right? If the run is longer, that means the rise is shorter. So if the run is longer, then it's going to have a smaller slope. I hope that makes sense. Okay, so what slope is this? This is right. Let's just talk about the signs right now. This is a negative over a negative. It's rise over run, negative over negative. And what is a negative over negative? It's a positive. So this is a positive slope. The way I look at it is, I look at it as, think of like a little car. Here's my cool car. I drew this in another lesson, and it doesn't look any different. I guess that's a car. You can laugh if you want. That's fine. You won't hurt my feelings. It is a little weird looking, but that's my car. So let's say from left to right, we're going where? We're going up the hill, aren't we? So again, we read left to right, so I'm thinking everything's left to right. As we go left to right, this thing is actually going up the hill. So that would be a positive slope. And you can see how it works out with the rise and run. Negative over negative is positive. Remember, we said we could also, if we wanted to, we could have done this. I could have started at the bottom, and I could have risen up to here, and then I could have ran. Oops, I didn't go far enough. Let's try that again. Let's rise a little bit more. I'm trying to get it right on there. And let's run. Let's see if I matched up. Yeah, pretty good. So I could have done that. If you look at it, it's the same thing. This is the rise. This is now a positive rise, and this is a positive run. Positive over positive is positive. All right, so either way you get to it, you still get the same rise over run. So you still have that blue line and this yellow line right here, the same length, and this blue and this yellow one are the same length. If I go rise over run, I'm going to get the same exact slope. All right, let's do one with, oh, you know what I want to do? Let's do this first. Just thought I'd talk about where does rise and run actually happen in like real life stuff. Here's something you might see. I don't know if you guys ever travel to the mountains or anything. My family's from West Virginia, and we go to West Virginia a lot, and you'll see signs like this all over the place in those steep mountains of West Virginia, Western Maryland. You'll see signs like this, and look, they give you it as a percent. What this means is this is a 7% grade. Now, of course, if we're in this lane, we're going down the hill. Look how steep it is. They're warning the trucks because it's really steep, and the truck's brakes don't always work so well going down a steep hill like this. They'll even have emergency pull-offs where you can, they'll have like the big sand pits and stuff where you could drive into it and slows you down. Anyway, this means for every 100 feet you go across horizontally, you're going to go 7 feet down. And so what is that? So let's think about this. For every 100 feet, we'll say that's 100. For every 100 feet you go across, then you go up or down. Okay, you could go, I tell you what, let's go down since we're going down the hill. I'm running out of room here. Okay, so let's say for every, this is probably not to scale, but that's okay. For every 100 feet you go across, you go, in this case, 7 feet down because it's out of 100. All right, and let's just do this. And here would be your slope. All right, it doesn't look like a big slope, but if you're in a big old tractor trailer, that's pretty steep going down right here. For every 100 feet this way, you go 7 feet this way. Now, this would be 7, and this would be 100. And so what would our slope be? Remember, it's rise over run. So watch this. Let's go from this bottom point to this top point right here. So I rise positive 7, and I run to the left, so it's negative 100. So my slope, M, is equal to the rise, which is 7, over the run, which is negative 100. And what is 7 over 100? It's 0.07, and what's 0.07? It's 7%. The negative, put a negative right here, the negative tells you which direction you're going. So watch, if you're in your big old truck, there's big old truck, okay, and you're going down the hill, that means it's negative slope. If you're going down the hill, it's negative slope. If you're going up the hill, it's positive slope. And that's what that means right there. So every once in a while, you may see that kind of stuff. Whoa, look at that. I switched things up a little bit, didn't I? Okay, I wanted a graph here. I wanted some nice lines. So I used this, this white background. So anyway, let's talk about the slope again. Let's say, let's put a point right here, and let's put a point, let's put it way over here like this. And let's connect them. And I'm going to go actually through both of them. It doesn't have to start and stop at those points. Okay, we'll just do that. So what I want to do is I want to find the slope of this line. If I wanted to find the slope of this line, what we do is we try to find 2 points. Now look, I wouldn't pick this point right here, would you? Because I don't know exactly where that is. Yeah, I know how far over, but how far down, I'd have to guess where it is. So what I would do is I'd pick this point, see where it goes right through the crosshairs, okay, of this graph. So I would pick that point, and if you look, I don't see anywhere else where it hits until right there. And it looks like it hits about right there. So I would pick those 2 points to find the slope of this. And so you don't have to draw these lines right here. I'm just going to kind of make it stand out a little bit. Right, let's make it a little thicker so I can see. All right, so hopefully you can see those. So what we want to do is we want to find the rise over the run. Now sometimes they'll do this. I just want to make sure that I cover this because they do in the book. And we're going to have some formulas later on, and it's going to be important. Let's call this point 1. So now I do know what the coordinates are, but let's just call it like x1, comma, y1. We'll say that's our first point, so that's my x and that's my y. I'll call this point, if this is my first point, I'll call this my second point, so that would be x2, y2. If I wanted to find the rise over the run, what we can do, and let's see, what would this point be right here? If this is x1, then this would be x1 as well, right, because it's right under the x. And what would the y part of this be? The y part would actually be y2. See, we didn't go up anywhere, so this would be y2. So if I wanted to do the rise over the run, what would the rise be? The rise would be, you would subtract the y values from each other. Okay, subtract the y values from each other. Remember, this is rise over run. So if I wanted to find how far it was from here to here, of course I could count, watch, 1, 2, 3, 4, that's easy, but we're just doing this in generalities right now, okay, just being very general. So this would be y1, this would be y2. How do I find the distance between them? I would just subtract y1 minus y2, and we've talked about that in an earlier chapter about the distance. And we've done this y1, y2 thing, I believe, as well. So how do we get from here to here? Or what would the distance be? You would subtract the x values. So this would be x1 minus x2. x1 minus x2. And that right there is your change in y. Okay, you find the change in y by subtracting the y values, and you find the change in x by subtracting the x values. So you'll see this thing right here quite a bit. It's a very popular way to show the slope. And that would be the formula. Okay, if I wanted to write put an m right here. If I wanted to write the formula for slope, it would be y1 minus y2 over x1 minus x2. Now look, I went this minus this. I went y1 minus y2, then I went x1 minus x2. I could have done the other way around. I could have said y2 minus y1 and x2 minus x1, but you just have to make sure you subtract them in the same order. All right, so let's actually find the slope of this without all this mess right here. Okay, I've gotten rid of all that junk, and now I've just got this line by itself. How do I find the slope of this? Let's find what this point was, first of all. This would be 0, what, 1, 2, 3, 4. And this point right here would be 1, 2, 3, 4, 5, 6, 7, negative 7, 0. All right, so if I wanted to find what the slope is the change in y over the change in x, which means what do you do with the y's? You subtract the y's from each other. Make sure you subtract in the same order, the x's and the y's. So let's subtract the y's from each other, 4 minus 0. And let's subtract the x's from each other in the same order. So if I started with 4, I got to start with this 0. 0 minus negative 7. 0 minus negative 7. And what is the slope of this? It's 4 over, minus a negative is positive, so it's positive 4 over 7. Now, you could have just counted, but what they're going to do in some of these problems is they're going to give you some ordered pairs. I'm just making these up off the top of my head here. They'll give you an ordered pair, negative 2, 3, and 5, I don't know, negative 1. And they're going to ask you to find the slope of the line between these 2 points. All right, you don't have to graph it, okay? You just know your little formula. So what's our little formula? You subtract the y's from each other. Remember, it's rise over run. Do the y's first. A lot of people get confused. They think x comes first, so they do the x on the top. No, it's the y's on the top, and then the x's on the bottom. Rise over run. So let's do that. Let's subtract the y's from each other. So this would be 3 minus negative 1. Make sure you subtract that one. And then let's do the x's. That would be negative 2 minus 5, and let's see what we get. Wow, I got the same exact slope. Isn't that crazy? Well, we got a negative, but it's the same number, and I didn't plan that out. Anyway, let's do this. 3 minus negative 1 is the same as 3 plus 1, which is 4, and this is negative 2 minus 5. Add a line, change sign. That's negative 7. So the slope between these 2 points right here would be negative 4/7, or 4 over negative 7. It's the same thing. Now, we've talked about positive slope and negative slope. Let's talk about 2 other types of slopes. And the first one would be zero slope. Zero slope. So what is that? Does it rise up like this, or does it go down? What is a zero slope? Here's a little picture to help you remember it. So when I think of zero slope, I think of being on skis, but not being on any hills. You ever done that before? I've never done any cross-country skiing, but pretend this is completely flat, completely horizontal. This would be zero slope, right? So if it's not going up a hill or down a hill, it's just completely flat, horizontal, then that would be a zero slope. So you can remember that. Now, if this person was just going to stand there, there was no wind blowing, nobody's pushing him, how fast is he going to go if he's not moving at all? If he's just standing there, right, and nobody's pushing him, he's not pushing off, how fast would he go? He would go 0. Or how far would he go? He would go 0, right? 0. He wouldn't go anywhere. So that is a number. So this is zero slope. So try to remember cross-country skiing on a flat surface, and that is zero slope. Oops, sorry. Let me get rid of this. There we go. Let's talk about zero slope very quickly here, I hope. Now, if I did zero slope and I had a line, watch this. Let's say I have a line going right here, and I wanted to find the slope of this thing. So I would take a point here, and I'd take a point here. Let's just pretend where this is. Let's say this is, I don't know, 5, 3. Okay? We'll say that point is over 5 and up 3. So what would this point be? Well, I don't know how far over. It looks a little further, so let's go negative 6. How far up would it go if it was a horizontal line? It'd go the same as this one, so that would be negative 6, 3. So if I wanted to find the slope of this, it's the rise over the run, or the change in y over the change in x. So what do? We subtract the y's from each other. 3 minus 3. And we subtract the x's from each other. In the same order, 5 minus negative 6, which will be a plus. Let's see what this is. 3 minus 3 is 0 over, this is going to be plus, over 11. What's 0 divided by anything? Well, it's 0. So what slope is a horizontal line? The slope is 0. And how can you remember a horizontal line has a slope of 0? Remember that cross-country skiing picture, and that should help you out a little bit. This next one is my favorite to talk about because I got a cool story to go along with it. I'll try to make it quick because I know you don't want to sit there all night watching this video. So let's say there's our x and y axis, and let's talk about a vertical line and what the slope of a vertical line is going to be. So let's do the same kind of deal. Let's put a point here and a point here. So let's just make up where this would be. Let's say this is like negative 5, 4, okay. And what would this point? Now this is directly below this, so it has to start off at -5, and let's say it goes to negative, I don't know, 3. I'm just making that up. All right? So I want to find the slope of this. The slope is the change in y over the change in x. So we subtract the y's from each other. 4 minus -3. Now we subtract the x's from each other. It's -5 minus -5. Oops. Minus -5. Let's see what that is. 4 minus negative, that's a plus, that's 7. -5, that's a plus. -5 plus 5 is what? It's 0. All right? What if we put that into our calculator? What if we divided by 0? So let's check this out. Put 0 divided by, 7. Let's get ahead of myself. 7 divided by 0. Let's see what happens. Oh, error. And it even tells you. You divided by 0, dummy. You can't do that, all right? So you're not allowed to divide by 0. It's undefined. It does not exist, all right? So a lot of times we say it's undefined. There's other words that people use. I kind of like that. I kind of like the idea of undefined. It does not exist. This is not 0. Don't say anything divided by 0 is 0, because it's not. We say that a vertical line has an undefined slope, or you could even say it has no slope. Some people get confused between 0 and no. No means it doesn't exist. 0 does exist. There is a 0 on the number line. Okay, 0 does exist, but no slope means it does not exist. There is no slope with a vertical line, or a vertical line is no slope. Think of it. If you went skiing, do you ever go skiing and look straight down and they say, okay, this is a triple black diamond, go ahead, go down it? No, they wouldn't. They rope it off and they don't let you go down it. All right. Now, there are some things that have 0 slope. Here's my story. And let's scooch that down a little bit. Now, I did this one day in my life, and I would like to do it more, to tell you the truth. But there was one day I did it. I was in college. I was in ROTC, and we went to VMI, Virginia Military Institute. And we were at the top of this thing, and it looked just like this. This is probably not the hill, I'm sure, but it looked just like this. It was on the campus of VMI. And they had all these Army ROTC Rangers there and stuff. And so it was my turn to get hooked up. So I got all hooked up. And I was kind of like this. I thought I was like this. And the guy's yelling at me at the top. He's like, let out a little more, a little more. So it looks like, see, this guy, he doesn't look quite perpendicular. But the guy was even yelling math words at me. He says, you need to get perpendicular to the, make that red. He says, you need to get perpendicular to here. And so, of course, I let out some more rope. And let's do this. Let's see if it works. Yep. And what I'm doing, I'm letting out like this. So, no lie. I know I'm completely perpendicular to this mountain right here. But, of course, what happens? The more you let out, what happens to my feet? My feet go up. Straight up like this. I'm completely upside down. The guy up there, the Army Ranger dude, he's yelling and screaming, don't move, don't move. Stay where you are. And I was so embarrassed. I was like, there's no way I'm going to let these guys come down and rescue me. And I wasn't that far. I was about this far down where this dude is. And I was like, there's no way I'm going to let them rescue me. So I was completely, I mean, no lie. I mean, I was, let's see if I can do this. I was completely like this. All right. My head was here and my feet are here and my arms are hanging onto the rope. I'm completely upside down. So I somehow, I don't know, I start rocking back and forth and he's yelling at me, don't move, don't move. And so finally I got my feet under me and then I just went down the mountain so quick. I went boing, boing, like this, and then down to the bottom. Now at the bottom were these big, huge boulders. All right. So my point is this. What does this have to do with 0 slope? Now, what if I would have fallen and I would have hit the rocks down at the bottom? Then there would be nothing left of me. I would not exist. Okay, I would be undefined. They probably couldn't even tell who I was because it was so far up and all these were rocks down the bottom. So I would be undefined. You would never ski down something like this. All right, so it does not exist. All right, that is no slope. A vertical line has no slope. And I got this other picture too that I found on the internet. I just found these on the internet. And this was kind of me. See how she's kind of tilted up like this? They made me go down and down and down. And all of a sudden my feet go whoop. up like this, and my head's down here and my feet are up here, and that's about how tall that mountain was. It was crazy. So anyway, there's my little story about no slope. Hopefully that'll help you remember what no slope is. Let's do another quick example and find the slope of this thing. So if I wanted to find the slope of this, what I'm trying to do is I'm trying to find a point where it lies on those crosshairs of the graph. You know what I mean by the crosshairs? Where the graphs intersect and come together. So I'm looking probably right there it hits. And where else? Probably right there. Looks like it hits right on in those two places. So if I wanted to find the slope of this, and I know this is kind of rehashing something we've already done, but there's a reason for this. Now watch. If I wanted to find the slope, let's just count. I'm not going to do all the number thing. Let's just count. 1, 2, 3, 4, 5, 6. So I went down 6. That's negative 6. Now I'm right here. Let's count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went negative 10. So my slope would be rise, which is negative 6, over run, which is negative 10, and that would be 6/10. We always reduce our fractions, so our slope would be 3/5. That's what the slope of this green line would be. Now what I'm going to do is I'm going to copy and paste this, and I didn't move the slant at all. I just moved it down a little bit. All right, so now let's do this. Let's find the slope of this. It looks like there's a point right here, and looks like there's a point about right there. Okay, let's do this and find the slope of this line. It's a different line. It's not the same line, but I copied and pasted it, and I just moved it down a little bit. So let's find the slope. Let's do this quickly. 1, 2, 3, 4, 5, 6. Again, look, negative 6. Does that sound familiar? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. So negative 6 over negative 10 is 6/10 or 3/5. Did you notice something? Hopefully you noticed it. This slope right here is no different than this slope right here. The slope, the lines are different, but the slopes are exactly the same. This is no steeper or less steep than this one right here. So what does it look like is true about these two lines? Yeah, it sure looks like they're parallel, right? And I know that they're parallel. I know they're parallel because they have the same slope. So parallel lines have the same slope. They're equal to each other. All right, so if I knew the slope of this, and this was 3/5, if the slope was 3/5, and I know I copied and pasted it and put it here, and I know I know they're parallel, I can tell you that the slope of this has to be 3/5 as well. What if I didn't know they're parallel? Well, if I didn't know they're parallel, I could find both of their slopes, and that could tell me that they're parallel. So if they're both the same slope, then the two lines are parallel. Okay, this is the last thing we're going to do. Look at these two lines. They definitely don't look parallel to each other, but let's find the slope of both of the lines, and you're going to find something that's fairly interesting about this. So let's find the slope of this line. It looks like it crosses right here. It looks like it crosses right here. So let's go rise over run. So I'm going to go from this point to this point. So I'm going to rise 1, 2, 3. So that would be, tell you what, let's do this in another color here and put the line so we can see it a little bit better. So we're going to rise that far, and we're going to run that far right there. Okay. And let's find out how far. 1, 2, 3, so that's negative 3, and let's run this way. We're going to go 1, 2, 3, 4, 5, 6, and that's negative 6. So what is the slope of this line right here? It's rise over run, which is negative 3 over negative 6, which is positive 3 over 6, which reduces to 1 over 2. So the slope of this line right here is 1 over 2. Let's take a look at the slope of this other line. Let's make this a different color. Let's make this green. How's that? Okay, let's find the slope of this green line right here. Let's see. Looks like it could cross a couple of these places. Probably crosses right here. It looks like it crosses about right here. So let's do rise over run with that. And let's go to this color. And so we're going to go here. We're going to rise this far, and then we're going to run this far. So let's count those up and see what we get. So let's rise 1, 2, 3, 4. I went down, so that's a negative rise, and then 1, 2 to the right, that's a positive run. So my slope of this line, this green line right here, is going to be negative 4 over 2, which is negative 2. So the slope of this green line right here, I'll put it right here, is negative 2. Now look at the two slopes. This slope was negative 2. This slope right here is positive 1 over 2. Now when I made this, I purposely made this so it's perpendicular to this red one. This green one is perpendicular, forms a right angle. All right, and I did that with the program. You didn't see it. I just didn't want to take up that much time. So look at the slopes right here. I've got the slope of one being negative, one line being negative 2, and the slope of the other one is 1/2. Here's what the book does. The book says if you have the slopes of two perpendicular lines, all right, these are perpendicular. Write it down. Perpendicular. All right, so these two lines are perpendicular. If I take the slopes of two perpendicular lines, it could be any two lines that are perpendicular. The slopes of any two lines that are perpendicular, if I multiply them together, put this over 1, look what I get. That cancels, I get a negative 1. So the product of their slopes will be negative 1. That's one way to look at it. I'd like to look at it another way as well. Again, you've got negative 2 and you've got 1/2. The phrase that I like to use, the phrase that pays, is that these are negative reciprocals of each other. Negative reciprocals. Did I write that? Reciprocal. Okay. They're negative reciprocals of each other, which means what? Negative means it's the opposite sign. So look, that's negative. What's this one? That has to be positive. And the reciprocals of each other. This is 2 over 1. What's a reciprocal? It's just when you flip the fraction. So if I flip this, I get a 1 over 2. So look, I've got a negative 2 and a positive 1 over 2. So they could give you some problems where they say, I'll tell you what, let's go to this. They could give you some problems where they say if the slope of, oh, it's a little too thick. The slope of one line is, let's say, 5/4. What would the slope of another line be if they were perpendicular? Okay, so if line 1, let's not do that. Anyway, if line 1 was perpendicular to line 2, if they're perpendicular, what is the slope of the other line? So if this line is 5/4, what's the slope of the other line going to be? Well, it's negative reciprocal. So it's going to be the opposite. This was positive, so ours is going to be negative. And what's the reciprocal of this? You just flip it. It'd be 4/5, negative 4/5. So they're not the same. They're actually completely different. They're a completely different sign, and you flipped the top and the bottom. Negative reciprocals. When do you do that? When the lines are perpendicular. Okay, so when your lines are perpendicular, they're negative reciprocals of each other. All right, that's basically it, I think. Let me take a look. I think I covered just about everything here, so that should be good. All right, if you have any more questions on this, if you want a little, probably shorter version of this, go to Khan Academy, and I haven't looked at his videos yet on this, but I'm sure he'll do a fine job talking about this. He probably won't have the cool pictures like I had in the great story about rappelling, but anyway, he'll do a good job. All right, that's it for section 3.3.